I feel like a stand-up comic here. There's like lights, and I can't actually see any of you. So it's an interesting thing. So thank you very much for the invitation. It's nice to be here and be. It's an honor to be a speaker when I look at the panel of speakers before me and after me and see so many friends. So it's really great. And what I'm going to talk about for the next 25 minutes is improving cardiovascular health with omega-3s and really touch on the evidence for this. Green button forward, good. And in terms of disclosures, the vast majority of my research is funded by the NIH. I do have an investigator-initiated trial on fish oil supplementation and post-op cardiac surgery, which is supported by NIH as well as several fish oil companies. And so as a cardiologist, when patients come to me and ask about their cardiovascular risk, or when a person on the street, thinks about their cardiovascular risk, as was highlighted by that video, they generally think about 4 risk factors: dyslipidemia or high cholesterol, high blood pressure, diabetes, and smoking. And those 4 risk factors are important. They've been highlighted through lots of studies and together can be used to determine a person's risk. But what I want to discuss and what this slide is supposed to highlight is 3 of these 4 risk factors are actually sort of midstream in the pathway of risk factors. And so if you look at cardiovascular disease as a continuum, with the worst outcome being death, and then several types of cardiovascular disease: heart disease, arrhythmias, heart failure, stroke, and cognitive decline, which is also a cardiovascular outcome for most people. You have symptoms and disability, subclinical disease, certainly high cholesterol, high blood pressure, diabetes, as well as other risk factors: inflammation, thrombosis, electrical disturbances like arrhythmias. These things all contribute to risk. But with rare exceptions, a few percent of the population might have specific genetic disorders. Other than those few percent of the population, all of these risk factors are not a normal function of the human condition. If you live a healthy lifestyle, a traditional lifestyle, both within the US or in other cultures, you don't develop these risk factors with time. You really have to have obesity, endothelial dysfunction, or metabolic dysfunction. And similarly, these risk factors only develop if you have poor diet, physical activity, and smoking. So really, these are risk factors for heart disease, and it's important that we measure blood pressure, measure cholesterol, treat diabetes, but they're midstream, and so it's very inefficient to treat these and look for these one at a time midstream, rather than focusing on the base of the pyramid, where really the risk is happening in the community, which is diet, physical inactivity, and smoking. And the most obvious symptom of this kind of inattention to kind of upstream is the obesity epidemic, where we've been spending so much time worrying about these risk factors, we've just forgotten about diet and activity, and we have the obesity epidemic. But really, what I'd like to do is have patients, when they come to the doctor, not just say, "What's my blood pressure, doc? What's my glucose?" but say, "Hey, doc, how's my diet? What's really important here? How's my activity level?" And we have done a pretty good job with smoking in the US, so that's been a success. We have to do the same thing with diet and physical activity. And so it's fortunate, when we want to consider diet particularly, that we've had really remarkable advances in nutritional science in the last 20 years. There's been really incredible advances. And so compared to what we knew in the 60s or 70s or even in the 80s and 90s, we know so much more about how diet affects the heart and diabetes and obesity than we knew before. There's really been these incredible advances. And some of those advances lead to changing messages. So we used to say margarine was good for you, eat butter, and then we said margarine was bad for you, it has trans fats, and now we say, well, margarine without trans fats better for you. Chocolate, bad for you, has fat. Wait, cocoa is good for you, right? There's these changing messages, but of course some of that is just the media picking up on one study and hyping it, but some of it actually is that the message has changed, the science has changed. And I think that for some reason in nutrition, that seems to bother people, bother scientists, bother the public, bother the media, that, wait, how come what you said 20 years ago is no longer true? But I think I don't understand why it's the only scientific field for which change bothers people. I mean, you don't go to the doctor now and say, hey, give me the best drug from 30 years ago, right? You want the best drug now. You don't say, give me the best procedure, the best stent from 20, 30 years ago. You don't go to a physicist and say, send me to Mars with, the shuttle or the science or the physics from 20 years ago. You want the modern science. So similarly, in nutritional science, we've had incredible advances. And there's been advances in terms of prospective cohorts where you study individuals, randomized trials where you study individuals and look at disease outcomes, randomized trials of risk factors, retrospective case control studies on top of what we had before, which is animal studies and some other ecologic studies. And so we have strong evidence. And when it comes to cardiovascular disease, I've put at the top these two types of studies, prospective cohorts where you look at tens of thousands of people individually and follow them forward over time, or randomized trials of disease outcomes, because when it comes to chronic disease, like cardiovascular disease or cancer, you really have to have the disease event. I can't just say, look, this risk factor improves, this treatment improves blood pressure, or this treatment improves LDL cholesterol, so I know it's going to be good for you. I really want to look at disease outcomes. And we'll come back to this when we consider fish oil and omega-3s. So this is kind of the summary. If we had to put all of nutritional science on one slide, I think this is what we know today. And maybe this will be updated and revised over the coming years, but I think right now this is solid evidence. There are things that we absolutely should be eating and things that we should be limiting. And the list is pretty short, actually. There's lots of things not on this list. The things that are not on this list, there's just not great evidence for or against them being important. But these things, I think, are all solid evidence. And you'll notice that things to eat actually outweigh things to limit. And so I think this has been a mistake of dietary guidance for decades, that we've been telling people, don't eat this, don't eat that, that's bad for you, don't eat this, instead of focusing on the good. And so the good, clearly, this is the list, and fish and seafood, I think, in terms of the strength of evidence, actually tops the list, and we'll talk more about that. So what are the omega-3s? And this is, telling all the experts in the room, people know, but there's basically the plant omega-3s, ALA, found in walnuts, soybean, flax, and the seafood omega-3s, EPA, DPA, and DHA. DPA doesn't really receive a lot of attention. It is in the diet, a little bit in fish, but DPA levels in the circulation or in tissues don't correlate with diet at all. So really it seems that DPA is coming from EPA, and there's retroconversion back and forth. And we've found, and others are starting to publish, and we have some unpublished work, that DPA is actually probably quite interesting as a metabolically derived omega-3. But these are basically the fish oil omega-3s that we're going to talk about. And I'll touch briefly on ALA again. So what are the potential health benefits? My talk title was all, I was supposed to touch on all the health benefits. There's just this is a very short list of all the things that have been reported as potentially being benefited by omega-3s. I mean, there's just an incredibly long list of potential things that could be improved. Cancers, diabetes, neurodevelopment, mood, AFib, non-fatal heart attacks, and so forth. I think that if you really look at the evidence objectively, there's only two things on this list that I think there's convincing evidence for. And I think the two things for which there's convincing evidence are cardiac death, death from heart disease, not non-fatal heart attacks, not all heart attacks, not total cardiovascular disease, but fatal heart disease, and neurodevelopment in utero and in infancy. I think there's very solid, convincing evidence that omega-3s benefits these two outcomes. All of these other things, ischemic stroke, mood, diabetes, inflammatory disorders, depression, I think there's emerging evidence, maybe even in some cases possible evidence, but I wouldn't be comfortable to say, yes, the evidence is solid, these are true. But I do feel comfortable for cardiac death. And we'll come back to this specificity for cardiac death later, because a lot of the randomized trials that are being done now are looking at total cardiovascular disease as the outcome, rather than just cardiac death. I don't think omega-3s have a major effect on total cardiovascular disease. They might have a small effect, but they don't have a major effect. Their major effect is in cardiac death. And I'm not going to touch on neurodevelopment in utero and infancy, but other speakers probably have or will. So let's talk a little bit about cardiac death. How do omega-3s prevent cardiac death? The great answer is we still don't know the exact mechanism. We don't know if it's a direct antiarrhythmic effect, which has been suggested by scientists like Alex Leaf and Kong here in Boston or others, or McLennan in Australia. We don't know if it's a direct antiarrhythmic effect at the heart, or if it's an indirect antiarrhythmic effect, for example, through lots of changes in ventricular function or autonomic function or other things. But clearly in primate models, non-human primate models, dog models, pig models, there's a clear antiarrhythmic effect of omega-3s, and based on observational studies and at least some trials in humans also, there's an antiarrhythmic effect. And what's important about this antiarrhythmic effect is that there's a nonlinear dose response. Okay, so if this is the dose of EPA and DHA in milligrams per day, 500, 1,000, and so forth, and this is kind of what you usually get in the diet, up to about 750 milligrams per day, most of the bang for your buck at these dietary doses is the arrhythmic effect, But if you keep going out to these higher doses, supplement doses, or like Japan or Norway doses of omega-3s, it kind of plateaus out, and you don't keep getting benefit. These other effects, there's many, many other effects. This is just a few. Triglyceride lowering is a strong linear dose response. Antithrombosis, or preventing platelet clotting, is very minimal until you get to higher doses. And then there's other effects like heart rate lowering, blood pressure lowering, for which there's probably also a little bit of a nonlinear dose response. And what this slide tries to summarize, the reason I'm talking about this dose responses, is this also helps interpret the science. So if we're looking at studies that are comparing people who are eating almost no EPA-DHA to people who are eating fish 2 or 3 servings per week, the major thing you're going to see in those people is an antiarrhythmic effect, prevention of heart disease death. If you're looking at supplement trials where people are getting 2, 3, 4 grams per day, you're going to start to see heart rate lowering, blood pressure lowering, triglyceride lowering, and maybe over years of intake, maybe those things could benefit other outcomes like non-fatal heart attacks, heart failure, atrial fibrillation. But at dietary doses, in the diet, mostly what we're going to see is prevention of death from heart disease due to a direct or indirect arrhythmic effect. And does anybody know the median, not the mean, but the median intake of EPA-DHA in the U.S.? The median 200, way too high. It's about 50 or 60. The mean is about 110, 120, because there's some people that are having a lot. But the median intake, which is the 50th percentile intake, is about 50 milligrams. The mean is about 110 or so. So we're way, way down here in the U.S. Compared to where we should be for getting benefits. So I'm not going to go into molecular mechanisms in great detail. There's this review that we published in Journal of American College of Cardiology last year, if people are interested. But it's really remarkable, the experimental studies. Omega-3s really do an incredible range of things. And it's because of their complex multiple double bonds, giving them really interesting three-dimensional structures. It's because of metabolites that they have. And there's just a range of things that they do, including affecting the membrane, affecting endoplasmic reticulum function, directly affecting DNA. Up here, we have Charlie Serhan is going to speak later today about production of resolvins and myrisins and protectins, really interesting pro-resolution of inflammation, metabolites. There's all sorts of mechanisms. I'm not going to go into these in detail. If there's interest in the questions, we can go into this. But there's just an enormous number of biologically plausible mechanisms where omega-3s affect our cells. If we look at actually the body count, which is what I said, we have to look at disease outcomes, right? What's the evidence that omega-3s actually improve disease outcomes in humans? This is the first study to look at sudden cardiac death in a large observational study published by a colleague, David Siskovic, in Seattle in 1995. So it's almost been, to do the math, it's almost been 20 years since this has been published. This is a retrospective case control study where they took people in Seattle who had basically had a ventricular fibrillation, a sudden death, and the paramedics arrived on the scene. They drew bloods from them. They took controls from the community. They drew bloods from them. And they compared the blood levels in the red blood cell membranes of EPA-DHA. And they found across quartiles or fourths that people in the highest 25% of levels versus people in the lowest levels had, this is risk, relative risk, they had a relative risk of 0.1, which means 90% lower risk of sudden death. 90% lower risk if you were in the top fourth of levels. This could be considered the omega-3 index, similar to the omega-3 index. If you were in the top fourth of the omega-3 index, you had a 90% lower risk than if you were in the bottom fourth in the U.S. population. And this was published in 95, didn't get a lot of attention, probably because the effect was so strong. But then it was replicated in the Physicians' Health study, in a prospective study, about 7 years later, published in New England Journal, almost exactly the same effect, almost exactly the same graph, a 90% lower risk of sudden death if you compare people in the lowest levels to people in the highest levels. Now, what I want to point out here is, what if you compare people here? There's not much difference, right? Once you get out above kind of this halfway point in your omega-3 index, sure, there looks like there's a little bit of additional benefit, but it's small. And this comes back again to interpreting trials. There's randomized trials being done. In randomized trials, what they do is they take everybody in the population and they give them fish oil. So if you're already here, or if you're already here, you're probably not going to get that much more benefit from taking the fish oil. If you're down here, this is the people that are going to benefit. So we have to think about that when we interpret trials, and we'll come back to that. So I'm not going to go into all of the other prospective studies in humans that have looked at the question, but let's just show you the summary here. This is through 2006. I could update this with about 4 or 5 more studies. Basically, studies have been done from countries around the world looking at tens of thousands of participants and looking at heart disease death. And overwhelmingly, these have shown benefits, that people who eat more fish, people who eat more omega-3s in observational studies have lower risk of heart disease death. It's one of the most consistent findings among nutrition and heart disease that you can find. Everybody who's looked at this has found this to be similar. And if you put this, all of these studies together, there's clearly in observational studies evidence. What about if you look at randomized trials? This is the list of currently published randomized trials that have looked at fish or omega-3s and heart disease death. And this is actually really nice because for most nutritional risk factors, we actually don't have randomized trials even studying them. So there's never been a randomized trial of fruit and vegetable intake to prevent heart disease. There's never been a randomized trial of nut intake. There's never been a randomized trial of whole grain intake. There's never been a randomized trial of olive oil intake, although one is being completed but hasn't been published. So for most things that we recommend, there's never been a randomized trial of salt, lowering salt for heart disease risk. So fish is actually relatively unique that we actually have trials. And not all of the trials showed benefit, and I'm going to show you a summary later, but at least some of them have. So at least some of these trials have shown benefits for fish or fish oil for heart disease death. And so if you put all of the evidence, excuse me, I'll show you that later. So this is a summary of the trials. The slide's a little bit small, but what I want to, the text is a little bit small. What I want to highlight is that not all the trials have shown benefit. So the relative risks are shown here. A relative risk less than 1 means benefit. So here's a relative risk of 0.68. That means 32% lower risk. If you look at heart disease death, DART, the first trial showed benefit. Giussi Prevenzione showed benefit. The second DART trial did not show benefit. Jealous trial showed benefit for overall coronary events. They had few coronary deaths. And Giussi heart failure showed benefit. So all of these large trials, 4 of 5 of them showed benefit. 3 trials have recently been published, all in 2010, that didn't show benefit. And so that's raised a lot of confusion about this. And if you look at the number of deaths, heart disease deaths, because that's really the outcome we should look at, they're very few. Only 138 in this study, only 57 in this study, and only 40 in this study. So the power, the statistical power to detect this effect has been much, much less compared to these studies, 1,477 heart disease deaths, 319 heart disease deaths, and so forth. So I'm not sure that we can say much from these more recent trials because they've been too small. If we put all of the evidence together from prospective cohort studies and at least 4 of the randomized trials that have been done through 2006, we get this really interesting dose response between the risk of cardiac death and the omega-3 intake. It's not a linear dose response. The more you eat, the more is not true that the more benefit you get. There's a really steep reduction in risk at lower levels of intake, and this seems to plateau out. And there's not a lot of data points out here, so maybe it keeps going down a little bit, maybe it goes down not at all, but it certainly doesn't go down, risk does not go down in the same speed as it does early in intake. And if we look at the overall reduction in risk, here, there's about a 36% reduction in risk with omega-3 intake. This is the confidence interval, so pretty robust. And so if you think about that number, that's about a 1/3 reduction in risk of dying from heart disease. This is the #1 cause of death in men and in women in the United States and in almost every country in the world. So we're talking about a 1/3 reduction in the #1 cause of death. That's a very powerful relative risk reduction. And if we look at the dose, where you seem to get kind of the biggest bang for your buck before it kind of flattens out, it's about 250 milligrams per day. On average, right? This is, people don't have to eat it every day. You could eat it once a week. It stays in your tissues. So it's about 2 grams per week. So I always ask this question and I always get funny answers. So how many calories per day is 250 milligrams per day of EPA and DHA? How many calories is that? It's 2, right? So 2.25 calories per day of a food, of a nutrient, and not a food, a nutrient, EPA and DHA, is giving a 1/3 reduction in the most common cause of death in this country. It's really an unbelievable effect. And every time I see this slide, I think this should be just being trumpeted off the rooftops. Now this nonlinear response, let's come back to this again. This is really important in interpreting the trials. Because in observational studies, what we do is we take people who are not eating any seafood, and we compare people who are eating modest or more, and we see this result, right? In randomized trials, they're just taking everybody in the population, and sometimes they're taking healthier people because healthier people tend to want to participate in trials. And if you look in those trials, the average intake is right in here. It's right around 150 or even higher milligrams per day. So the ability in a randomized trial to add fish oil and get a little bit extra bang for your buck is small. It's not said that it can't be done. Some trials have done it, but you need big trials and lots of events to see this benefit. So I think that we have to worry that trials that are taking people up here, or even worse, taking people that are up here and giving them fish oil, may not see a benefit for heart disease death. They may see benefits for other outcomes if there's long enough dose and long enough follow-up. So I think this is really kind of the take-home message. Now, if you do meta-analyses pool all the data together. Each of these lines here represents a meta-analysis. This line represents 1, a relative risk of 1, no effect. Each of these dots represents what the meta-analysis found, and the lines are the confidence interval. Meta-analyses of total mortality have shown suggestions towards lower reduction in total death, but not statistically significant. If you look at total heart disease, it's also modest. And if you look at heart disease death, which are these last 3 meta-analyses, there's pretty consistent reductions. And here's the relative risks, again, about 35% lower risk. So it really seems that the major bang for your buck, at least at most doses, is heart disease death, which maybe has a modest effect on total death, but it's really heart disease death. If we come back to the strength of evidence, so what lines of evidence do we have that omega-3s reduce risk of heart disease death? Well, we have animal studies. I didn't go into all the details, but we have an enormous range of animal studies, including in non-human primates. We have ecologic studies. People who live in countries with higher omega-3s, like Japan, have much lower rates of heart disease death than in other countries. We have prevalence studies where people who have higher fish intake have lower risk of heart disease. We have retrospective case control studies like the one by Siskovic et al. We have lots of randomized trials in humans showing in a range of effects of omega-3s on beneficial risk factors. We have extremely consistent evidence from prospective cohorts of disease outcomes. And then we have at least some evidence from randomized trials. I dotted this because some trials haven't shown a benefit, and I worry about that. It would be great and make me feel more comfortable as a scientist if all of them showed exactly the same thing. They don't. There's different reasons why they might not. As I said, some are smaller. Maybe they're giving it to people who are already eating enough fish. So there's reasons, but it's still a little bit concerning that the evidence isn't perfect. But there are at least some trials that have shown benefit here. So I think that this is among the most strong, powerful, and consistent evidence that we have in nutrition for heart disease. So I think that if we want to prevent heart disease death, fish and omega-3 should be really the first-line treatment in the population. What this slide shows is the absolute risk of heart disease death and the number of sudden deaths per year in the population. So if you look down here, this is somebody who's had a heart attack, has ventricular tachycardia or arrhythmias, has reduced heart function. They have almost a 30% risk of sudden death per year. So that's a person, they get an implantable defibrillator. Right? They're at really high risk. But they don't represent that many people, so the number of sudden deaths per year is quite small in the United States. Then you look at people, let's say, who've just had a heart attack, any heart attack. Right? Their risk is about 7% per year of sudden death. So, in this, you give them drugs, you do what you can. They still don't represent a lot of sudden deaths. There's more of them, but there's still, not as many as in the total population. The general population, if you just take everybody in the community, they have a very low risk of sudden death, about 1% or 2% per year. But that's where all the people are, right? That's where all the people are. So this is where most of the sudden deaths are happening. About half the time somebody is diagnosed with heart disease, it's because they died, right? About half the time you get your first diagnosis of heart disease, it's because you died. So for those people, we have no treatment that we can give them that will prevent that other than lifestyle and diet. And so for the general population, fish and omega-3s should really be the first-line treatment for primary prevention. Just going to wrap up here with a couple of slides. This is ALA, the plant omega-3. This is similar meta-analyses, total heart disease death, and one trial that has been done. And again, the line of no effect is here, and you can see that the confidence intervals, the statistical significance crosses the line of no effect. So I still don't think we can say that plant omega-3s have the same benefit for heart disease. Maybe they do. We need more studies, but right now we can't say that plant omega-3s will replace seafood omega-3s for this same benefit. To end on some comments about dietary guidelines, there's actually been 2006, but then more recently 2008 and 2010, and these were published last year, the 2020 goals for the AHA. There's been 5 major reports from the US and other countries and international organizations about dietary guidelines for fish consumption. They're all converging and saying exactly the same thing. which is that people should eat at least 2 servings per week of fish, preferably oily fish. And if you have to talk about EPA and DHA, people say 250 milligrams per day as a target minimum. Doesn't mean you can't eat more, but that's a target minimum for the population. Very consistent recommendations across all organizations. And so what percent of Americans are actually doing that? This is the percent of U.S. Americans meeting dietary guidelines. And so for fish or shellfish, the proportion of Americans eating at least 2 servings per week of fish is about 20% of adults, and that's not, in many cases, oily fish. So it's only about 20% of adults, 1 in 5, and only about 10% of children. So well below where we should be in the population. And we did an analysis that we published 3 years ago now, looking at U.S. deaths due to major modifiable risk factors. Smoking was the #1 cause of death, about 450,000 deaths in the United States per year, with about a third being cardiovascular in black, about a third being cancer, and about a third being lung disease. High blood pressure was the next major cause, obesity. These aren't surprises as major causes of death. But when we looked at all causes of death, low intake of dietary omega-3s was in the top 8 here. Right, in the top 10 as a top 10 cause. And it's about the same effect as high salt, high LDL cholesterol, and for cardiovascular disease in black, high blood glucose. It's a major effect we estimated for prevention in this country. And if we look globally, this is unpublished work, but we've hopefully going to submit this in the next couple of months. We've looked globally at omega-3 intake, collecting about 300 nutrition surveys from around the world, and using statistical methods to fill in the missing data, using other covariates. This is global seafood omega-3 intake among men in 2010. It's pretty similar among women. This is grams. So where you want to be is above 0.25, above 250 milligrams per day. You want to be in the green. And you can see most of the world, the vast majority of the world is in red or yellow, which means well below intakes. And there's some exceptions in Europe and some places where there's a lot of seafood intake, but the great majority of the world is below where we should be for seafood omega-3s. So thank you very much. And this is, if you want to translate this into fish to achieve 250 milligrams per day, this is the number of servings per week of fish you would need to eat to get 250 milligrams per day. So, farm salmon or wild salmon, you'd have to eat about a serving or serving and a half per week to get 250 milligrams per day. Catfish or cod, you'd have to eat about 10 servings per week because of the huge omega-3 differences. So the type of seafood also makes a difference for getting the omega-3s. Thank you very much.